Today I'm talking about digital audio recording, how to build an awesome digital audio workstation, DAW for short. I talked in the intro about the main component, the computer itself, and some considerations about that. Today we're talking about software, hardware, and most importantly, architecture. I got into the recording world as a musician first and then producer. The whole engineering side of things was kind of a necessary evil then that I had to pick up along the way. If that's where you're coming from, if you're a musician and you want to get into recording, I think you're going to find this video very, very helpful. The first question that most people ask right up front, what multitrack software should I get? The software you're going to run is going to be the main thing that you're interacting with. It's what you're recording with and mixing on. So it seems like a good place to start. But the truth of the matter is that it really doesn't matter that much. All the multi-track software applications basically do the same thing. Yeah, they look a little bit different. They might use slightly different terminology, hide things in different places in the menu. But whether you're talking about Pro Tools, Cubase, Logic, those are probably, historically speaking, the three bigger ones, or a free version like, Cakewalk, or an inexpensive newcomer like Reaper or something. The bottom line is that they all accomplish the same essentials. For now, let's set the whole question of software aside and let's zero in on what really is important. The hardware converters are hands down the most important thing, but probably not for the reason you're thinking. When we're going to go shopping for something, anything really, most of us will compare two things basically, cost and quality. And with that mindset, we start shopping. We might read some reviews, look at some head-to-head comparisons, read the brochures, look at specs. And if we go about it that way, we're probably making a big mistake. The fact is, any professional level converters, anything outside the box, meaning outside the computer, are going to be more than adequate to do a good job for a project studio. It's just not that expensive these days to produce a reasonably high quality converter. Now don't get me wrong, I'm not saying that there are no differences between any of the converters. There are differences, but they're very subtle. Smoothness, fatness, perceived color, things like that. And if you're not an experienced producer, you're probably not even going to notice. Here's the thing, a lousy song with a lousy performance and poor production skills isn't going to be saved by a $10,000 set of converters, okay? On the other hand, though, if you have a good song with good performances and reasonably decent production skills, you can get a good quality product out of what would really be budget or entry-level professional converters. Furthermore, you should realize that the DAW has a lot of components in it, and a chain is only as strong as its weakest link. So it really wouldn't make any sense at all to put all your money into super quality converters and use mediocre mics, for example. If money is no object, well, sure, buy the best converters available. That'd be great. And throw in an SSL console while you're at it. But on the other hand, if your budget is limited, if it's severely limited, realize that entry-level converters are going to do just fine. Focusrite, Mark of the Unicorn, Behringer, Mackie, whatever. It's about function. That's what we really need to understand before we start looking at specs. It's about ramifications, not specifications. So let's talk about that. Some converters have no knobs or controls whatsoever. It's just a box. Some have a single level control or a trim for each channel, and then some are full-fledged mixing boards. There are different numbers of channels. Some are 2 channels, 4, 8, 16, and more. How is it that all these converters accomplish the same thing? Well, they don't, at least not in the same way, and that's the crucial thing. But before we get into that, we need to back up a little bit and look at the bigger picture. The first thing you want to think about when you're going to build your DAW is what is it that you want to do with it? Do you want to just record your guitar over pre-recorded backing tracks? Do you want to use an amp farm plugin to get your tone? Or are you going to mic a speaker cabinet? Maybe you want to record original music, you want to demo your songs, and that means you're going to record vocals, bass, guitar, keys, drums, whatever. Do you want to record live drums, or do you just want to use a virtual drum set inside the box? Maybe you just want to record other bands. Different tasks require different capabilities, and the different capabilities are either enabled or disabled by the hardware you choose. That's why I say that choosing the hardware is the most important thing. On the one hand, it's a waste of money to buy a whole bunch of capabilities that you're never even going to use. On the other hand, though, you don't want to limit yourself from moving forward and being able to do what it is you really do want to do. So ideally, you'd want to know exactly what you want to do with your DAW. And as we move through this video and you understand more about the implications of the different architectures, you could select the hardware that will enable the architecture to do what it is you want to do in the best way possible. But in a lot of cases, if you haven't done this before, you might not have the experience to know how you want to go about doing some of these things. In that case, I'd recommend you write down what it is you want to accomplish and then write down those questions, put some question marks there. As we move forward and talk about architecture and the options that different architectures enable, then what you could do is price out your DAW maybe in two different ways. Maybe the simpler way might cost a little less, and then maybe a way that might be a better setup and allow more options, but would cost a little more, and then of course you can weigh those two things. In any case, the next step is to start looking into the details of the how. Part of what makes a DAW so confusing to set up is that there are so many options. There isn't just one way to do it. To make a good choice then, what you really need is a general sense of the lay of the land. What types of products will allow the function that you need? Having figured that out, then you can look at specific products within that category that are also within your budget. And then with kind of a structural overview in mind, you'll kind of know what you're doing, and you might have to dig through the menus a little bit and figure out, where things are in any particular software. But since you know the goal and you know what you're looking to accomplish, you understand the why of it. And if you understand that, then you're really going to understand your system, and you're going to understand how you want to put your system together. And the best way to do that is to make sure you know the fundamentals, the DAW basics. So let's start there. All of our sound sources produce electrical signals, so they're analog. To get into the computer, we have to digitize it, and that's what the converters do. So we hit the AD converters, and AD just stands for analog to digital. Now we can plug it into the computer. Usually that's a USB cable. After it's in the computer, we can do whatever we want with it, process it, route it, whatever. Then the digital signal that we output from the computer goes back to the converters, but this time we hit the DA converters, which are digital to analog, run a cable from the output of the converter to our monitor speakers. Now we can listen. So that's the basic DAW architecture, but there are a lot of wrinkles in this that we're going to get into. Your computer already has digital converters in it. Your mic input, that little 1/8 inch or 3.5 millimeter jack, that takes an electrical signal from a microphone and digitizes it so that your computer can deal with it. So that's the AD converter, and then it hits DA converters on its way to the headphone jack. And you could listen in headphones then, or you could do an adapter and run it to a stereo. So the truth of the matter is, your onboard audio on any computer, it already makes your computer a DAW. All you need is the software and you're in business, right? The only problem is that those converters basically suck. They're very low quality. They're consumer grade for one thing, and it's also worse because of the fact that they're actually inside the computer. Well, that's a terrible place to attempt to do digital audio conversion, to attempt to do it well, at least, because it's a very noisy environment, electrically noisy, a lot of RF noise, and converters need good shielding. That's why professional converters have always been outside the computer box, and that's why you need to upgrade. The question is to what? There are basically two categories. The one on the left, it's just a box, and there are no knobs or hardware controls. There are plugs on the back, XLR and 1/4 inch, to get in and out of the thing, but there are no hardware controls at all. And then the one on the right, the converters are in there, but it looks suspiciously like a mixing board. Type on the left, without any controls, it has all its controls in software inside the computer, whereas the one on the right allows you to control everything with hardware. And this is a huge functional difference. Now, in reality, these two categories are blurred because there are a lot of products that are somewhere in between. They'll give you some hardware controls, but then require some software controls. On top of that, of course, all mixers aren't equal. Some offer a lot more flexibility and control than others. But thinking in terms of these categories is still valid because anything that requires software control has profound implications and limitations for how you can set up and run your DAW. That first category of products with no knobs or controls tend to be a little bit less expensive because there's less to physically manufacture. All the controls are made via software inside the computer, and that's a more cost-efficient way of doing things. And while I'm all for saving money, there's a big catch to these products. And it's something that you're not going to read about in the brochures, they're not going to tell you, but it applies to everything that's in that category. If you don't also have an external mixing board, all converters of this type will require that you run your monitor bus inside your computer and manage it through software. On the other hand, that second category that look like mixing boards have combined the converters and the mixing board together in one unit, and that will allow you to run your monitor bus outside the computer. This, I think, is by far the biggest choice when it comes to designing your DAW. It's the architecture issue of where's the monitor bus. Is it inside the computer managed with software, or is it going to be outside the computer? Because there are big ramifications to those two different choices. And to understand how that's going to affect your workflow, you really need to understand what a monitor bus is and what it does. This term monitor bus is engineer speak, but it's something that we really need to understand. It's a simple concept, but if you don't really get it, you're never going to understand your DAW. First of all, what's a monitor? Well, on a computer, of course, it's the screen, because that's what we're paying attention to, that's what we're interacting with, that's what we're monitoring as we work on the computer. But in the world of audio, we're dealing with sound, so we monitor the sound. That's why we call the speakers that we're listening to monitors. It's what we're paying attention to, it's what we're listening to. And the other word, bus. What's a bus? Well, a bus is a thing that people get on and it takes them from point A to point B, right? In the audio world, a bus is a signal path that allows audio signals to get on, and we take them from point A to point B. So put those two ideas together. What's a monitor bus? It's just the sound that we're listening to. It's the audio signal that's going to get sent to the speakers. But isn't that the same thing as the mix? Well, no, it isn't. The monitor bus includes the playback mix from your Multitrack software, but it also includes the live sound from any instruments you're playing. You have to hear what you're doing if you're going to perform it. The monitor bus probably also includes a click track, which is generated from your Multitrack software. And it's not part of the mix per se, but it is technically included within the output of the Multitrack. And there are other sound sources too that you want to dump into the monitor bus. Maybe you take a break in the middle of recording and you want to pull up a YouTube video, listen to a song. Or maybe you want to pull up this awesome video and watch it again. In order to hear it, your browser has to dump that sound into the monitor bus too. Everything that you need to listen to needs to come into the monitor bus. So the monitor bus is sort of a higher level mix. It's an aggregate mix of all sound sources. It's bigger than just the mix coming out of your Multitrack software. Now, I already said that there are two ways you can run your monitor bus, either inside the computer managed with software or outside the computer. Now we're going to talk about the pros and cons of each of those two different methods so you get some idea what you're actually signing up for when you choose a particular set of hardware. First, let's look at running it inside the computer. This diagram shows the architecture, and it looks kind of messy, but it's really pretty simple. You got your instruments coming in, plug your cables into your hardware converter, the output from the hardware converter goes to your speakers, a USB cord goes to your computer, And all the heavy lifting is done in the computer. The Multitrack software is there, but notice the green thing, there's another software mixer, and that's the software that handles the converters. The job of that is to control the monitor bus. So the monitor bus is inside the computer, and you've got some other software there in the computer too, of course, and any software that you want to hear at your output through your monitor speakers has to come into that green mixer, has to come into the monitor bus. And when we bring that monitor bus inside the computer, there are a few significant ramifications. We immediately run into an issue called latency. Whenever you take an audio signal and you run it into the computer, it's digitized, but then it has to run through the CPU and the RAM, and you process it, maybe you EQ it or compress it, add some reverb. All that processing takes a little bit of time. It's not a lot of time, but it's a couple of milliseconds. And that slight delay from the time that the signal enters to the time that the computer gets it processed and kicked back at the output, that amount of delay is called latency. How big a problem is latency? Well, it depends on what you're doing, and it depends on how much you've got. Latency is measured in milliseconds. So what is a millisecond? Well, it's 1,000th of a second. But practically speaking, what is a millisecond? Does it matter? At sea level, the speed of sound is just a hair over 760 miles an hour. That works out to 1,116 feet per second, slightly over 1 foot per millisecond, or 3 milliseconds per meter. What does that mean? Well, it means that if you're sitting at your studio monitors and your ears are 3 feet away from the speakers, there's a 3 millisecond delay right there. That's not a problem, though. We experience that as instantaneous. As you sing or play, a couple of milliseconds doesn't bother us at all. But now that you add the computer, let's say you add another 3 milliseconds of latency, now you're looking at 6 milliseconds. That's still probably not a problem. That would be the same as a zero latency system with the speakers 6 feet away from your ears. What about 10 milliseconds? Well, that's probably still okay, but it kind of depends on what you're doing. It might be a problem. And if it's more than that, it's most likely going to be a problem. Suppose, for example, you're trying to sing in headphones. Well, the headphones are your voice having been processed with this latency. So if they're 15 or 20 milliseconds delayed, that gets combined with the sound of your voice in your own head, which of course is zero latency. And that mismatch is probably going to create a serious problem. There are, of course, workarounds. There are ways that you can minimize the impact of latency. For one, probably don't use headphones. Too much latency makes headphones virtually unusable, in my opinion. But if you take the headphones off and you just hear the sound in the room, it might not be such a problem. But of course, that creates other problems. If you're singing into a microphone, you're not, number one, not going to hear the mix as well, so you're probably not going to perform as accurately. And on the other hand, you're also getting bleed from the sound of those speakers in the room coming through the microphone, and that's going to mess up your mix to some degree. Dealing with latency with kind of workarounds like that is really trying to polish a turd. If I can't get the latency under 5 or even 4 milliseconds, I find that to be unacceptable. I don't want to record like that. The better solution is to reduce latency to make it as small as possible. How do you do that? Well, the first thing you want to do is you want to use the most efficient drivers in your system. And what are drivers? Well, drivers are the software that sits in between the hardware and the operating system, so the operating system can talk to the hardware, and then it passes that information directly into the application that you're running. So drivers are essential in the Windows platform. Now, another plug for Macs. If you're on a Mac, you don't need the drivers. The system will automatically connect into the hardware because, frankly, it's a better system. But in any case, if you're on Windows and you're using drivers, the drivers that you use are very important. Use what are called ASIO drivers. That's an acronym. It just means audio stream in out. They're the drivers that the hardware manufacturers have tuned and tweaked and written to be the most efficient, and that means you get a lower latency. On top of that, usually ASIO drivers will allow you to set the buffer level. What's a buffer? Well, of course, you probably know if you have a slow internet connection, you're watching a video or something and it stops and the thing starts to try to buffer. Well, what's happening is data's coming in unevenly. The data packets come in, in kind of fits and spurts. So we need a little area to store them so that we can hand them off in a stream continuously so that we can run it in real time. Whether it's video or audio, the buffers are important. The larger the buffer, the safer it is. The more uneven the data can come in, and then we can spit it out evenly. But larger buffer means more latency. On the other hand, the smaller the buffer, the lower the latency, but it's also a bit more dangerous. We're kind of flirting with disaster because if we have a digital dropout, you start getting, pops and clicks in the audio, both on playback and on recording. So that's not acceptable. So the bottom line is we want that buffer to be big enough so that we don't have problems, but we also want it to be as small as we can get by with. And how do we do that? Well, this is where a faster computer helps, for one thing, but even a fast computer, if it's bogged down with a whole bunch of background processes, it could still create buffer underruns and create problems. And that's why you might want to minimize background tasks so that you can get that buffer as small as you can. Computers supposedly multitask, doing more than one thing at a time. Actually, they don't. What they really do is switch back and forth really fast between the different tasks. So what your computer's really doing when you're running these background tasks and running your audio is it's taking data and it's throwing it into the buffer, and then it stops that, jumps over and does this other task, and then it jumps back to the audio, and one hopes that it jumps back fast enough to keep filling the buffer before it runs dry. So this whole thing of latency is kind of down this rabbit hole of more and more issues, software problems, wanting the faster computer and everything else. But what if I told you that there was a way that you could actually have zero latency all the time without any concern about buffers or even the speed of the computer? With an external mixing board, you can run your monitor bus outside the computer. The signal from our live instruments is plugged into the mixing board, and that's where it hits the digital converters. Then, those digitized signals of each channel are split. They run through the USB cable to the computer, where they get routed to the inputs of your Multitrack software, and at the same time, each signal also flows through each channel strip in the mixer. And that means you could EQ it, add compression, add effects, without affecting what's being sent to the computer. The signals from the live instruments then go into the monitor bus, which is the output of the mixer, going directly to the speakers. So those faders are going to control the relative volume of each of your instruments in your monitor bus. You'd plug the main output from the mixer into your monitor speakers, in which case the main out fader down there at the bottom right will feed the volume level to the speakers. Although in some cases your mixer might have a control room knob that is actually post main fader, and that's often what's used to control the volume to the speakers. That's kind of a hangover from the old days when we would run a mix to tape and print it to tape. The output of that main out would be hot because that's what would actually be feeding to the tape machine that is recording our mix, and therefore we'd tap that signal, send it to a control room knob, which would enable us to attenuate or turn the volume down for the signal that's going to the speakers. In that case, your volume would be controlled by the series of those two together. Next, let's look at how sound comes out of the computer from the multi-track mix into the monitor bus. Everything that goes back and forth between the computer and the mixer is going through the USB cable, of course. So you'll have to go into your Multitrack software and configure the main outputs of your Multitrack to be whatever inputs in the mixer you want that signal to come in on. Most commonly, that will be the last stereo input. So if you have a 16-channel board that's made for use with DAWs, there would most likely be an extra stereo input channel, channel 17 and 18, that would be intended for the output of your multi-track mixer to plug into and thereby get into the monitor bus. If not, you'll just have to use a couple normal inputs. And of course, there's also other software in your computer that is making sounds, whether it's a browser or a stereo editor or just the alert sounds of the computer or whatever other sounds that you want to bring into your speakers. They're going to have to come in on a different set of software inputs. Now, you might be wondering, well, the computer still has latency, right? Because, you look at the ASIO drivers of the software and it'll tell you how many milliseconds it is. For example, here in Cubase, I'd go up to the Studio menu, select Studio Setup, then click Audio System, and here you'll see the ASIO driver being used is the Q16. That's my mixing board. And you'll also see the latency, input and output, just a little over 8 milliseconds. If I go here, I can go to the control panel and I can adjust the buffer size. It's set right now at 256 samples. If I drop it, let's say to 128, my latency falls to under 6, and I can drop it more if I want. Try 32. Now I'm under 4 milliseconds. But I actually run it up here because I don't really care about latency. Since I'm using the monitor bus outside the computer, my performance isn't affected by latency at all. So I can live with a little bit larger latency, and it's safe and there's no problem. And by the way, if you're wondering about the latency that I'm showing here, understand that if you're not running your monitor bus through that software, it doesn't really matter because your live performance is not delayed, and that's the key. The only thing that the software latency in this setup is affecting is how quickly the software responds to play and stop and record buttons. And 8 milliseconds is so fast for that stuff that it feels virtually instantaneous. Now, in the old days of hard disk recording, the converters were always separate from the mixers. I actually used one of these for years, a Mackie VLZ 16-channel board. You can get something like this for maybe $250 or $300 used. But this, of course, would be one way to get your monitor bus outside the computer if you already have converters that don't have any hardware control. But this is a live mixing board. It's not intended for use with a DAW. And what that really means is it doesn't have the USB communication directly back and forth with the computer. So with something like this, you'd need separate hardware converters. The better solution is to combine the mixing board with the converters, because now we get the best of both worlds. We can listen in real time with zero latency, and we go through the converters once, and then it's off into the computer. So a quick word of caution as you're piecing a DAW together and you want to use a hardware mixer for the zero latency monitor bus, not just any mixer will do. You need one that is specifically for use with a DAW, which means it'll have a USB out that'll communicate directly with the computer. Later on, with the advent of faster computers, lower latency, it became possible to put the monitor bus inside the computer, but there's more. There are pros and cons. Let's talk through those. The first thing is that it is a little cheaper, all other things being equal, to use the hardware converters that are not a mixing board. But that's really not very significant because you can also buy very inexpensive small mixing boards that do allow you to bring the monitor bus outside the box. Nevertheless, I put it on the side of cost savings to put it inside the box. Understand it's not much. The next issue when it comes to latency is a no-brainer. Get it outside the box. You're going to be a lot happier there. And then the third thing is ease of use. When the monitor bus is outside the computer, you don't have to switch between active windows constantly in the machine. So I pull up my Multitrack software. I just work in the Multitrack software. I never have to bounce to the software of the hardware converters. But with the other system, if I want to make a change in the monitor bus, let's say I want to turn up my live guitar or turn it down a little bit, I have to switch active windows. I have to find the channel that is the one I want with the mouse, click it, drag it, and move it the amount. And then I'm playing guitar, so I'm using my hands to play guitar. I have to grab it, move it, play guitar a little, oh, that's not enough, grab it, move it again. Okay, on the other hand, how much easier is it just to do this? And you might say, well, is it really that big a deal? A couple of clicks and a mouse, I can handle that. But you got to realize that chances are you're going to be making adjustments to your monitor bus, hundreds of times throughout the session. So every time, it's 3 or 4 clicks plus, 200 times, that's an awful lot of clicks, and that's really kind of an annoyance. Do you really want to work like that? Another problem, if you're anything like me, is that running your monitor bus inside the computer is very abstract. It's kind of hard to hold in your mind, the structure of what it looks like, where it's going, and what it's doing when it's abstract. I'm kind of a visual thinker, so if you're a visual thinker, it's a lot easier to think in terms of, okay, here's my channel, here's my sound source, here's the cable it runs in, etc. It's easier. When I used to run a DAW with the monitor bus inside, I would have to draw up diagrams, stuff like this, in order to understand the signal flow. Anyway, I'm obviously pushing pretty hard toward the external mixer solution, the zero latency option. I think that's hands down a much better plan. I've done it both ways, and I would never go back to doing it inside the computer. For example, here are a couple of very inexpensive DAW mixers. The one on the left is a Mackie Pro FX6. It retails at $169. The one on the right is the Pro FX10, and that retails at $249. So these are pretty inexpensive converters that allow you to get your monitor bus outside of the computer, zero latency. Let's quickly walk through the signal routing using a simple mixer like this. Now they label it as a 6-channel mixer, but really there are only 2 full input channels. And then channels 3 and 4 are actually just a stereo input, left and right. No real controls on that at all, except for this level knob, which is a volume. Don't know why they didn't actually put it in the same box with the inputs, but there it is. And here's the stereo input 5.6. This time it's an 1/8" stereo input for plugging in the output of a phone or something. Now this mixer also has 2 stereo software inputs through the USB, coming in from the computer. USB 1.2, the other one USB 3.4. Press that USB 3.4 button in, and then whatever you route in the software to USB 3.4, well, that signal is going to show up now here in the mixer in channel 5.6. And similarly, any signal you route to USB 1.2 in the computer is going to show up here at this blend knob. And it dumps directly into the mains, into the monitor bus, through this blend knob. And this is important because a lot of DAW mixers, as well as stripped down hardware converters, now offer this kind of monitor bus blend knob. The idea here is that you're overdubbing over a mix. So say you're singing into a vocal mic, you need to hear what you're singing over, the mix coming out of the multitrack, and you need to hear yourself. So what this blend knob does is it allows you to adjust that mix with one knob really quickly. Turn it to the right, you hear less of your vocal, you hear more of the mix coming off the multitrack. Turn it to the left, you hear more of your vocal and less of the backing mix. Another thing that you might want while you're tracking is you might want to dial in some effects, but you don't really want to record those effects because they might not be what you want in the final mix. Why, you might wonder, do you need effects as you're recording? Well, if you're a singer and you're used to, singing live, suddenly putting on headphones and just hearing your dry voice can really throw you. It doesn't sound normal or natural. So you need a little ambience, a little bit of reverb. Well, this little mixer allows you to do that. These are all different effect presets. You can press this button here and send the signal into the effects loop, and the amount of effect that you'll hear in your monitor bus will be controlled here by this knob. But again, you're not actually recording it. It's only live. Same thing if you were recording guitar and let's say you were doing a solo that was a big soaring solo, so you wanted some delay to get the right feel, but you don't want to record that delay. Select the delay in the effect unit here, and you can dial that in and listen to it as you perform, but you're recording without the delay so that you could use whatever delay in the multitrack, stereo or ping pong, or do whatever kind of delay you want, put it wherever you want in the mix, EQ the delay, do any number of things to it. Now let's move on. There's also a separate headphones volume, which is indispensable because as you're tracking, you'll want to turn your monitor speakers down so that you don't get bleed through the microphone and just put the signal in the headphones. And then when you're done with your track, maybe you want to take your headphones off and listen back through the monitor speakers. So an external mixer certainly does offer a little more control over your monitor bus. The smaller mixers will, of course, be a little more crimped on features. The larger mixers will offer greater flexibility. But even if you go for a hardware converter that isn't a full mixing board, a lot of them are sort of hybrids that will also allow zero latency monitoring. This SSL unit, for example, retail at $269, has really great converters in it. The PreSonus is more of a budget level at $99, but both of them offer zero latency monitoring. This is exactly the same thing as that blend knob. To the left, you hear more of your live mic. To the right, you're going to hear more of the mix coming back from your multitrack. These are going to be somewhat more limited though than the mixer. First of all, you don't have any effects loop here, so if that's important, you definitely want to steer toward a mixer that has that. And you'd have no EQ, no low roll-off, and no dynamic control, which you'd get in some of the more sophisticated mixers. But in any case, it is a zero latency solution. And with zero latency solutions being so inexpensive, I have to wonder why anyone would run their monitor bus inside the computer. Obviously, I'm a big proponent of zero latency, and I'm going to tell you, you're probably better off to get a mixer and run your monitor bus through the mixer. But there are a couple of considerations. If you're going to do it like that, then you can't really use software plugins like an amp farm or something, because obviously you have to go into the computer and monitor through that in order to make that work. However, there is kind of a hybrid setup where you could use both of these systems sort of together. A multi-track program like Cubase, for example, will allow me to look at my input channels, and here you can see that my microphone that I'm recording in is coming in on multiple channels. Actually, I have it routed to more than one right now. But in any case, if I wanted, I could come up here and this channel that I'm recording in, if I wanted to monitor it, I could press this button. And now I'm actually monitoring through Cubase, meaning Cubase is taking that input signal and putting it at the output. You can hear I'm getting a little bit of feedback in the room because I'm monitoring actually two at the same time. If it were loud, I'd have a feedback loop, so you don't want to do that. But in any case, if you turn off your monitor through your normal means and only monitor through Cubase, then I could insert the effects here in this channel. This would be my insert effects, and I could put any effect I wanted, and I could put a reverb in there, or I could put an amp farm in there, or do anything else I wanted. So what you could do is, if you wanted to use an amp farm or something, you could be generally using the mixing board to have zero latency, except when you wanted to run a software plug-in inside the monitor bus. Then you'd just mute the signal on the mixing board, or pull the fader down to 0 so that you're not monitoring it there. Instead, you're going to monitor it through the multitrack. So however your multitrack handles the monitor, different programs are going to be a little bit different. And what that really means is that the multitrack will take that input signal and it will put it at the output, meaning it will now be in the mix. Then you're going to, of course, monitor on your mixing board, you're going to monitor the output of your multitrack as you normally do, and your signal's going to show up there. So that's how you would run your monitor bus inside the computer if you wanted to use some software plugins and you were using a zero latency hardware or mixing board monitoring bus outside the computer. Now, of course, when you do this, that signal will be subject to the latency, whatever your multitrack software says that you're running. Mine right now is about 8 milliseconds. Most of these DAW mixing boards will allow you the choice of where to tap the signal out of the channel, sending it to your DAW. Now, these cheap guys are not going to give you that. Basically, anything that you do to the signal that you're going to hear live, that is the signal that's going to be passed to your DAW. So if you make an EQ adjustment, or in the bigger one, you also have compressors on channels 1 and 2. If you dial in a little compression, that signal with the compression is what's going to be passed on into the mixer and recorded, along with those changes. Now, the better mixing boards won't do that. They will give you the option of where to send it. So you could send the signal to the USB post-trim, or you could send it post-trim and EQ, or post-trim EQ and fader, post-trim EQ compression. You could add any of those elements if you wanted, but you could also take them out. I don't want any of that crap recorded, okay? I want to record raw tracks. The reason I want to always record raw tracks is because anything that I can do to the signal going into it is something that I can do when it's in there coming out. But if I do it going in, there's no turning back. I've done that to the track. I can't undo it. But if I record the raw track, then I have total freedom to do whatever I want to do, in the mix, whatever's called for. There are some exceptions. If you have enough experience and you know with absolute certainty that the change that you're doing is moving it in the right direction, well, there's nothing wrong with a little EQ or a little bit of light compression coming in, but often that's not the same amount that you might want to use to get a good performance. Okay, so trying to get a good monitor mix that allows a good performance out of you, it kind of needs its own thing. And then on the other hand, the mixing kind of needs access to do whatever you want to do. So that's the reason why I always record to the DAW. I always record post-trim, but pre-EQ, pre-compression, no effects. I try to go as dry as possible. With guitar, there are exceptions. If you want to record a guitar sound and you have effects like on a pedal board, that's pre-distortion effects. Well, of course, you need to do that. That's part of the sound of the guitar that you want to record. And of course, that's a whole, big subject in itself, the difference between pre-distortion effects and post-distortion effects. So I'm sure all that's clear as mud, but I'm hoping that it gives you at least some basis of understanding what the fundamental different architectures are, the pluses and minuses of each one, and at least direct you, as to how you might want to set it up. It's really, though, of course, experience and using the thing that's going to fine-tune your skills and fine-tune your preferences over time. I'll go into more details in the next video about my setup in particular, how I have it set up, and why I do it the way I do. But for now, let's go ahead and move on, talk about the next issue, which is the number of channels. If all you're going to do is record overdubs, one vocal performance at a time, one guitar performance at a time, all you really need is one input. Okay, you just use the same thing over and over. Of course, typically they come in sets of 2 because that allows for a stereo input. So that's generally, practically speaking, the minimum number. Why would you need 4, 8, or 16 or more? Well, if you're going to record a live band, you need all those simultaneous inputs, right? Every single mic, every single input is going to need to be on a separate channel. When I used to record a lot of live drums, I actually found I needed 16 channels of input. You might think 8 would be enough, but frankly, it's kind of crimped, and I'll explain why. Typical drum set is probably kick, snare, maybe 3 toms, hi-hat, ride, and some overheads for a stereo spread on the crash cymbals, the metals, okay? So how many mics is that? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 mics on the drum set. Right there, we're over 8. But still, it's even more than that probably, because when I'm going to track, I also probably want to record the scratch takes. That would be like somebody playing along with the drummer in order to, get them into the feel of the song and so they know where they are and they don't get lost and that sort of thing. So, maybe you've got a bass and a guitar and a vocal running. Typically, I would want to record those scratch tracks too, even if I'm not going to use them, just to, to help, when I set up a playback mix for the drum set and whatnot, I'll be using some of the other instruments in there to kind of help give it a realistic flavor. So right there, I'm up to 10, 11, 12 tracks. If you don't do live drums, though, probably are only going to need 2. Why would you go in between? Why would there be a need for 4 channels or 8? Well, maybe if you, were recording a duet or something, 2 acoustic guitars, a couple of vocals, 4 or 8 might be fine. When it comes to number of channels, though, and you're looking at these mixing boards, you have to be careful, though, because they're all about trying to tell you, all of the great things that their mixing board does, and they basically look at every input and call it a channel. So, for example, this is the Pro FX 12, which would suggest it has 12 channels, but if you look at it, you see really there's only 4 individual channels with full controls. And then you've got 3 more channels that are stereo channels, 5, 6, 7, 8, 9, and 10. But if you plug an XLR into them, those actually become mono channels. So really you're looking at 7 channels. Finally, let's talk about control surfaces. A control surface is hardware that controls the software inside your computer, so you don't have to go in and grab the mouse and move your faders and EQ. You can do it right on the hardware controller. generally for a project studio, I'd suggest that you just forget about this idea of hardware controllers. You know, for a long time, I had in my mind this idea, how nice would it be to have that system where you'd be able to, you know, literally touch and move the faders and control everything. You know, it'd be the best of both worlds, right? Because you've got, you know, the digital environment with the ability to edit and the ability to save every detail, get exactly what you want, and you've got a hardware control surface, so you don't have to be moving the mouse. Well, I gave up on that after I tried it a few times, because unless you can go all the way and get a huge console, it's probably just more of a headache than it's worth. If you've only got an 8 or 16 channel hardware controller and you're running a 40 channel mix, well, what you have to do to get to the extra channels is you hit a modifier button, and then, you know, 1 through 8 suddenly becomes 9 through 16, and then 17 to 24, and you do a segment at a time. And on the surface, that seems, well, I guess that's, you know, pretty functional. But the truth is that in your multitrack, you've got different colors, you know, in your arrangement window, and different colors on your mixing board for the channels, so you can find things pretty quick. But on your mixing board, you really can't. You go and jump from 17 to 24 or 25 to 32, and it's like, well, wait a minute, which one is this? And then if you're going to spend all your time creating, you know, tape strips and writing down what everything is for each layer, well, you know, you're going to be at this all day long. This is just ridiculous. It's a whole lot easier just to mix inside the multitrack, and I find that using the mouse in that environment really isn't a problem at all. In fact, most of my mixing actually happens not on the mixing board inside the software, but it happens in the plugins. It's the insert effects, because I'll grab and I'll use this particular compressor, you know, because I want its color, I want its tone, and what its unique characteristics are. So I pop that one in. That, of course, changes levels. And then I'll use a limiter. Then I'll use, you know, other effects and so forth to help generate the sound. This is how I'm crafting the levels and the tones. You know, it's mostly done in those insert effects. So hardware is not going to do any good for that. You know, you have to do that in the computer anyway, so what's the point of the hardware controller? In the next video, I'll go into studio monitors and room treatment, and I'll also give you a walkthrough of my system in detail, showing you how I set it up and why I'd set it up that way. But if you want to watch that, you're going to have to join me on my Patreon page, tier number 7. Be sure to subscribe and click the notification bell.